So there are these three allowances when we do pattern making: shrinkage allowance, draft allowance, and finishing. This table gives you standard values of shrinkage allowance for different types of materials, right? That aluminum, zinc, aluminum, copper, gold, white iron, and so on. What is the percentage contraction, right? 7%, 6%, 4%, 2%, and so on. So these are the percentages by which the volume will contract, will shrink, isn't it? And some metals are very strange that upon cooling they expand. So bismuth, silicon, and gray iron, these are very special materials which expand a little rather than contracting. If you remember, water, right, like everything, when water is solidified, it contracts, it reduces in volume. But you remember anomalous expansion of water between 0 to a little lower temperature, there is some temperature range. In that temperature range, water first expands when it solidifies and then it contracts again. So these also are those strange materials like water and ice which will expand. But all normal metals that are used in casting shrink. So if we know this shrink percentage, then we have to make the pattern size, pattern volume longer by this. Generally, rather than this percentage, they give it the shrinkage allowance in millimeters per meter. Millimeters per meter. They give that, so that if we are to make, say, 0.2 millimeter, then this much percentage of length should be increased and so on. So of course, yes, you see, we here give you just an idea that we have shrinkage allowance and finishing allowance and draft allowance, and shrinkage allowance for many known metals is like this. So we can calculate the pattern size based on this. In real experience, when you are in an actual factory, you will be given all the help you can, and these values will be known in more detail. So this was all about the fluid flow and the heat transfer and the thermodynamics and the design of the sand mold and so forth, right? All these things were related to the design of the sand mold. Now a totally new topic, as I said, this reddish brown or maroon red means a whole new topic. So melting practice and furnaces. Melting practice and furnaces. What are the machineries? What is the equipment involved in melting of these metals and alloys in the casting? So melting furnaces, right? Most commonly used furnaces: cupolas, direct fuel fired, crucible, electric arc, induction. So all of these we will study in a little more detail. What are these types of furnaces? How do we select which of these furnaces is good for us? Furnace selection. So what are the factors? The casting alloy. Which metal are we going to cast? Its melting and pouring temperatures. Melting is one thing, but the pouring temperature will be some superheat. So what was the casting alloy and what was the melting temperature and the superheat? Capacity requirements. What sizes do we need? A small, large, and so on. Cost of investment, right? Each type of furnace will have a different type of cost in the beginning. So investment, operation, and maintenance. We should never look at the initial cost only. Maybe something has a very high initial cost, but its operation and maintenance is low cost. So we should always look at all of the three, not just in furnaces. In anything, you are going to buy a car, don't look at the price today if you want to keep it for 5-6 years and then sell it. So then over the 5-6 years, investment initial, operation cost, and maintenance cost, and what do you get at the end, right? So here also that. And then environmental pollution considerations, because more and more governments around the world are becoming stricter, which they should, in environmental laws. So which furnace does less of that and so on, right? So these are the factors based on which a foundry will select that for their range of products, which type of furnace they will use. This decision has to be done in any engineering facility, that if we want to produce these type of things, then what is the best equipment and tools and machines and so on. Best does not mean cost. Best means initial cost, running cost, maintenance cost, easy to do, no pollution, right? Lots of things, easy to train, safer. So lots of things are there. So the first one, cupola, right? Cupola. The word is coming from some Greek Latin, but this is now an English word. What is a cupola? Vertical cylindrical furnace. Vertical cylindrical furnace equipped with tapping spout near the base. Tapping means from where you take out the metal. So a cylindrical vertical furnace where you take out the metal near the base. Cupolas are generally used only for cast irons. Right? Big statement. If you remember your material science course, we had phase diagrams and engineering alloys. In that, there was iron carbide phase diagram for all steels and irons. Whether it is a steel or whether it is a cast iron, it is an alloy of iron and carbon. If the percentage of carbon is very high, then instead of steel, we get cast iron. It is another type of steel, you can say. It is called cast iron because this is the best metal to be used in casting. And there are hundreds and thousands of different things being made which are of cast iron. For example, in the car, do you remember what is made of cast iron? There could be many things. Yes, you are right if you are saying that the engine body, the whole engine block is made of cast iron. There are so many complicated shapes and figures and you see places for the plugs to go, for this to go, for that to go, that you cannot machine it and so on. You do it by casting and you do it from a cast iron. Then of course inside you put a lot of steel and this and that. So if you take even just this one part, the engine block of an automobile, then there are millions of them being made around the world. Just this one part. So there is a huge amount of melting in a cupola. And of course there are many other things. You see, you take any motor, you take any generator, basic body of all of these are generally made by cast iron. Okay. Although other furnaces are also used, the largest tonnage of cast iron is melted in cupolas. The charge means the material that we put inside the furnace, and then this material will melt. So this is called the charge. So the charge consists of iron, coke, flux, and any alloying elements. Iron, you know, coke is a pure form of carbon. Flux is something which you add to make the things smooth. And if there are any other alloying elements in the cast iron, any other phosphorus, this, that. So this is the charge, mainly iron, coke and flux. Iron, coke and flux. And if there is any other alloying element, and then it is loaded through a charging door located less than halfway up the height of the cupola. Okay. They say that a picture is more than 1,000 words. So rather than describing the cupola, there is this diagram. This is in a sense a schematic diagram. A schematic means that you show how the machine or whatever it is works, equipment, but you don't give the exact materials and dimensions and so on. But this is sort of in between. This is a very well drawn drawing showing you all the features and showing you almost the correct sizes and so forth. So this is a little more than a schematic. It is a very beautiful diagram of a cupola. At the bottom, if you see this, there are big supports because this is a huge big thing, very heavy, and a big support is needed. And because it will be very hot, so it is not directly in contact with the earth, right? It is at some distance away from it. So this is one thing. Then this whole body is a cylinder, right? That is what we said in the beginning. It is a cylindrical furnace, At the top, of course, there is all the exhaust system and so on. There will be a lot of toxic gases and so forth. So that is very important, and this could be connected to a central exhaust system in the factory or whatever, right? So that the real exhaust goes at a very high altitude in the atmosphere. The outside, this outside here and the outside here is a steel shell, right? Because you have to make a very big and a strong cylinder, so you make it of a particular type of a steel. But inside, if you see inside here, these bricks that you can see, refractory lining. In many earlier courses, you have heard of this word. Refractory means high temperature resistant. High temperature resistant. So outside it is a steel box cylinder, and inside there are bricks or tiles and so on of very high temperature resistant ceramic. Because if the whole body is of steel and you are melting cast iron and steel inside, the whole thing will melt, right? So the outer body for strength and manufacturability is a steel, but it is lined inside with a high temperature resistant ceramic, which is the refractory lining. Here, if you see charging floor, where you stand, and then there is the charging door. So you put all the charge. Remember, charge was the solid iron ore and coke and flux and so on, right? So the charge is fed from here. This is the charging floor. Then if you see wind box and blower, because you need very high temperatures, it will either be gas fired or sometimes it is oil fired, but you need very high temperatures, and air needs to be blown continuously inside so that the burning is very efficient and so on. So a big wind box together with a blower is there. Once it is melted and so on, there will be lots of impurities. All the impurities will float slightly above and all the pure metal will go down. So the pure metal from here, if you see the tapping spout, so the pure metal is tapped out from here. But here, if you see this door, this is slag and slag spout. In all metallurgy, slag means the impurity metals that have to be removed, right? So the slag floats a little above the pure metal and it is tapped outside. So this is the slag spout, and that is the tapping mechanism for the pure metal. At the bottom there is sand. Again, for safety, sand is also a refractory material. Sand is also a type of ceramic, right? So this is there. So this whole thing is your cupola furnace. It's a very huge, big furnace, right? And this is the furnace most commonly used for cast iron and so on. If we visit some industries where this can be done, then you can actually see it. You can go to the YouTube, internet, and you can see more actual pictures of a cupola furnace. The next one is direct fuel fired furnace. Direct fuel fired furnace. It is a small open hearth. Open hearth means open to the atmosphere. Cupola, remember, was closed from all sides in the steel cylinder. This is open hearth. So this is open. This is a standard name for any furnace which is open to the atmosphere. But it is a small in size, in which the charge is heated by natural gas fuel burners located on the side of the furnace. Okay. The furnace roof assists heating action by reflecting flame down against the charge. So there is a roof at the top, heat goes up and heat reflects back. At the bottom of the hearth is a tap hole to release the molten metal, of course. And generally it is used for non-ferrous metals. Non-ferrous metals which do not belong to the iron and steel category, such as copper-based alloys and aluminum alloys and so on. So relatively small furnaces which are directly burnt by burning of gases, right? And this is direct fuel fired furnace, and generally for non-ferrous metals, copper alloys, aluminum alloys and so on.